In this video, we're going to talk about a box plot. So a box plot is also known as a box and whiskers plot. So this is a graphical device that simultaneously displays several of the measures of central tendency and dispersion that we have discussed before. So the box plot highlights the first and the third quartiles, the median, and the extreme values of our data, allowing us to easily identify these descriptors. And our first and third quartiles, quartile 1 and quartile 3, our median, which is also our quartile 2, and our extreme values, the minimum and the maximum values, the minimum value, the smallest value, and the highest value, the maximum value, is what is known as our 5-number summary. So again, the 5-number summary consists of our minimum value, quartile 1, our median, which is our quartile 2, our quartile 3, and our maximum value. So, how are these values highlighted in the box plot? So, this is an example of a box plot. As you can see, here is our box plotted in an axis, and the reason why it is also called box and whiskers plot is because of these lines here, which we can call our whiskers. So, as you can see here, we have here 1, 2, 3, 4, 5 highlighted numbers, and this is actually our 5-number summary. 5-number summary. So first, we have here our minimum value, the smallest value in the dataset. And this is our quartile 1. This is our median, which is also our quartile 2 rather. This is our quartile 3, and that is our maximum value. Now, if you would remember as well, this, which is actually quartile 3 minus quartile 1, is actually already our interquartile range, meaning this box here represents already 50% of our distribution, while the other 50% that I will encircle in blue ink is this one here, the one in the whiskers. Those are the other 50%, this one and this one. That's part of the 50%. Now, because we know that 50% of our data is actually here, we can draw it as if it's a curve from a histogram. So we can draw it similar. I'm going to make it like that, and I'm going to draw something like this. As you can see, since more than 50%, or at least 50% rather, is on this side, then we can assume the same when we draw it as a histogram and as a curve. So, do you remember the numerical descriptor that tells us something about shape? That is our skewness. So even in the box plot, we can see the skewness of our data set, of our distribution. So in this specific case, as you can see, more of the values are here on the left side, as also shown in our trial curve drawing. So we can say that this is positively skewed distribution. So the box plot can give us a lot of information. The shape of our distribution, whether it's positively skewed, symmetric, or negatively skewed. It can also give us an idea of where our data are concentrated on. So in this case, on the lower left side, also related to the shape. And it can also give us idea based on the numerical descriptors. However, it is not easy to construct box plots in Excel. So what we will focus on is how we interpret box plots. Even more, box plots sometimes do not have the 5-number summaries on them, and they're written on a vertical axis. That does not matter. All we need to do is just lift from this previous one here. This was our axis. We're just going to make it up just like our usual axis. Now, if you might have noticed, in this specific box plot, we have these dots. They are outside of the whiskers. So these dots here are what we call our outliers. And if you would recall, when we talk about outliers, these are the values that are beyond the following numbers. When we compute quartile 1 minus 1.5 times IQR and quartile 3 plus 1.5 times IQR, those are the numbers that we call outliers. Now, just to clarify, if our box plot is like this, the outliers are already inside the whisker. So there are box plots wherein the outliers are inside the whisker. There are box plots where the outliers are outside the whisker. So we just have to double check. Now, how do we know? In box plots, outliers are dots, not part or not a line or not a segment. So that's where we can be sure that we have outliers. And these values here are the numbers that correspond when we compute our boundaries, if you may, we would know that they are outliers. Since we do not have values here, all we can do is probably describe its shape. So, as you can see, most of our values are here in the lower part. Lower part. So that means we have small values. More of them is actually 50%. 50% of our values are quite small. So that means we can say that this is, again, a positively skewed distribution, meaning we are expecting we have much more low values, and we have quite a lot of outliers in this distribution. So mainly, a box plot can tell us the following. If it's labeled, we can get the 5-number summary. 5-number summary. We can also get the shape or the skewness of our distribution. And if there are, the box plot can also give the outliers, because there are box plots that show outliers, there are box plots that do not show outliers. So let's try to analyze more box plots in the next video.